Welcome back, ladies and gentlemen. Mr. Shaw here, ready to help you out for Unit 6 of Algebra 1, Semester 2, Solving Systems of Equations. So what I did was I kind of made a quick video here to show you how to do these problems. Again, they're like the pretest and the test, but they are not the same. So again, if you take notes on this video and then you do the exact same sorts of things, you will be successful on your Unit 6 pre or post test. So let's get right to it. All right, so first off, we're going to solve by graphing, but I actually don't need to. I want to kind of get you used to the idea of solving algebraically and graphically. So let's go ahead and do this. So what I'm going to do is I see that they're both equal to y. So I'm going to go ahead and I'm going to set these two parts of the equation equal to each other. So it's going to be 3x minus 2 equals 4x plus 6. So after I find x, then what I can do is I can plug it back in for one of these equations, and then we can find the y value, and then we can graph them and make sure that we're correct. Anyway, so again here I see I have a 3x over here and a 4x over here, so I'm going to subtract 3x from both sides. And then on this side I'm going to subtract 6 from both sides. And so now I'm left with negative 10 equals x. So x equals negative 10. And then we're going to go back and we're going to plug this in for x up here. So this is going to be y equals 3 times negative 10 minus 2. And then let's just solve. So y equals negative 30 minus 2. So y equals negative 32. So my graph, my answer then is going to be negative 10 comma negative 32. And that would be the answer you select for your ordered pair. However, we need to also graph it, and I'm going to actually just get rid of this graph because it is going to, and I'm going to just draw it manually because negative 32 is a ways down. So let's look and see what I can do here. All right, so that's a terrible straight line. Goodness gracious, Mr. Shaw. Let's try again. No. Here we go. We got this. We got this. It's getting worse. Oh my gosh, this is a disaster. And I'm live right now. All right, that's going to have to do. Okay. So anyway, we start here for the first line. Let's do this one in red. It's going to be start at negative 2. And then you're going to go up 3 units and over 1 unit. So 1, 2, 3. And over 1. And this is our graph. Oops. Don't know why that went away. So this is our first line. And then in blue, I'll do the next one. So this is going to be plus 6 to start for my y-intercept. So 1, 2, 3, 4, 5, 6. And then I'm going to go up 4 and over 1 unit. So 1, 2, 3, 4, and over 1. And then this is going to be, oops. And this is going to be my second graph. And you see they're gonna cross like way down here at negative 10 comma negative 32. Anyway, this is not a great one. I just made this example up as I went. I apologize. But again, if you do follow these same steps, again, you will be more successful than I was in this particular example. Again, so you look for your ordered pair and then graph them. Make sure you graph them correctly, and then your ordered pair should be the same. Like where the two lines cross should be the exact same as your ordered pair that you found. All right, moving on to substitution. So you see that I have y equals x minus 2. So what I'm going to do is I'm just going to put that in parentheses, and I'm going to plug this in for this y up here. So let's do it. So 3x minus, now again, it's going to be 2 times, instead of y, I'm going to write x minus 2 equals 6. So now we distribute. So 3x. So negative 2 times x is negative 2x. and then negative 2 times negative 2 is positive 4 equals 6. So now I combine like terms, so this will be x plus 4 equals 6. Last step, subtract 4 from both sides, x equals 2. So that's the first part of my ordered pair. Now I just go back here and I plug it in for x. So y equals 2 minus 2. So y equals 0. So my answer for this one is going to be 2, 0. Moving right along. All right, elimination is next. There's going to be two elimination questions here. Again, the first one's really easy. The second one, you're going to have to do one step first. So in this case, you're looking for the ones that are, basically, you're going to add these equations together. And when you do that, one of them needs to cancel. One of the variables needs to cancel. So you see here, when I start adding these equations together, I have negative 3y up here and positive 3y down here. So when I add them, now I'm going to get 5x, these y's cancel, equals 4 plus 6 is 10. So now we divide by 5, x equals 2. Easy enough. Now we want to go back and plug it in up here in this first equation. So 2 times 2, oops, my bad, minus 3y equals 4. So now 2 times 2 is 4, minus 3y equals 4. Subtract 4 from both sides, and you get negative 3y equals 4 minus 4 is 0. Divide by negative 3, and y equals 0. So apparently I was just really obsessed with the ordered pair 2, 0 for this video. My mistake. But that's your gain. So again, for elimination for question number 3, just make sure you add the equations together. One of them is going to cancel out. One of the variables will cancel, and then solve for the remaining one, and then plug it back in to finish your, or just to find your answer. For number 4, the next elimination question is going to be a little bit harder. Again, you need one of the variables to cancel, and in this case, you see I have 2x and 3x. That's not going to easily cancel. I'm going to have to multiply both equations in that case. In this case, though, I have a negative 1y and a negative 3y. So what I can do is I can multiply this whole equation here by negative 3 on both sides. And so what's going to happen then is this is going to, I'm going to draw it down here now. So this will be negative 6x plus, again, negative 3 times negative 1 is positive 3y equals 7 times negative 3 is negative 21. So now I'm done with this equation, so I'm just going to get rid of it. And now I can eliminate my y's when I add my equations together. And that's going to be 3x minus 6x is negative 3x. Equals negative 3 plus negative 21 is negative 24. And now we just solve. So divide by 3, or by negative 3, excuse me, and x equals positive 8. And now I just need to plug it back in. So I'm going to go up to this equation up here, this one right here. I'm going to plug that in, that x in, that 8 in for x. So 3 times 8 minus 3y equals negative 3. 3 times 8 is 24. Minus 3y equals negative 3. Subtract 24 from both sides. And you're left with negative 3y equals negative 27. Divide by negative 3. And y equals positive 9. So your answer then will be 8, 9. And there you have it. Moving on. All right, so the next one is an inequality. Okay, we've got y is greater than negative 2x plus 1, and it's asking if 2, 3 is the solution. So I've got x and y here, and I'm just going to plug these in and see what we get. So it's going to be 3 is greater than negative 2 times, again, for x, we're going to put 2 plus 1. All right, so negative 2 times 2 is negative 4. So 3 is greater than negative 4 plus 1. And then negative 4 plus 1 is negative 3. So 3 is greater than negative 3. And so what you're looking for, is that a true statement? So 3 is greater than negative 3. So this is true, and that means the answer is yes. All right, 3 more to do. First up here, we're going to go ahead and knock out the graph of y is less than or equal to negative 1 over 3x minus 2. So we're going to draw these the exact same way. The things that you need to understand, guys, is that if you see an equal bar underneath, like if it's basically looks like this, greater than or equal to or less than or equal to, that's going to be a solid line. And then if it's just greater than or just less than, that's going to be a dotted line. So let's do it. So we're going to start here at negative 2, that's the y-intercept. Then we're going to go down 1 and over 3 units. You see that this is less than or equal to, so it's going to be a solid line. Something like that. And then the last thing is our shading. So for shading, if it is, let me do this in red maybe, if it is less than or less than or equal to, you're going to shade down, like below the line. And then if it's greater than or equal to, you're going to shade up or above the line. So in this case, it's less than or equal to, so we are going to shade down. So for your answer, you're looking for a solid line with shading below the line. All right, second to last one, here we go. Y is greater than 3x plus 1. So again, we'll start at 1. We're going to go up 3 units and over 1 unit. And you see that our graph is just greater than, so no equal bar, so this is going to be a dotted line. Something like this. So now we just need to shade. So you see it's greater than, so we're going to shade above the line. One easy way to tell where the shading should be is where if you put your pencil like right on the y-intercept and you go up, like that means that this side needs to be shaded. And so this is what you're looking for. So on your graph, on your answer, you're looking for a dotted line with shading above the line. All right, last one. So this is going to be a system of inequalities, and so we just need to graph both of these, and I'll show you how to do that here in just a second. So for this first one, though, we want to go ahead and solve for y, get this into y equals mx plus b form, and then we can graph both of them. So let's do it. So we're going to subtract 4x from both sides. So then we're left with 2y is less than negative 4x plus 8. Divide by 2, divide everything by 2, and you're left with y is less than or equal to, sorry, just less than, excuse me, negative 2x plus 4. Okay, so let's graph, I'm going to graph this one in red, and I'll graph the top one in blue, and then we will do our shading, and we'll call it a day. All right, so starting here at positive 4, going to go down 2 units and over 1 unit. And you see this is a dotted line because it's just less than. So dotted line here. And then the shading is going to be below it. I'm not going to get too crazy yet because I still need to graph my other line. So let me do that first. This one's going to be in blue. So start at positive 1. And I'm going to go down 1 and over 2 units. This is a solid line. So something that was really terrible. Let me try again. It's hard to draw straight like that. There we go. A little bit better. And then it says greater than, so the shading is going to be above. Like that. So in general, this, like, I would focus on make sure that you guys have the right lines. Make sure that one of them is solid. Like just pay attention to the inequalities. So if you have, just check and make sure you see you have a equal bar here, should be a solid line. No equal bar here should be a dotted line. And then make sure your shading is correct, and that should be the easiest way to tell what the actual answer is. So in this case, the answer is going to be this shaded area in here. But my guess is that they will still have like all of this other area shaded. So that just don't get confused with that. Just make sure you guys stay focused with, you know, the correct lines, and then the shading is correct in general, and you guys should be just fine. Anyway, I hope that helps you. If you guys have any questions, shoot me a message on Canvas. Otherwise, have a lovely day.